Really cute.
Yeah.
Okay, I'll just see.
Oh, what am I trying to do? How's your day, Creeper? That's good. How's calc today? Nice, nice. It is what it is. It just is what it is, yeah. Calc is calc. Did you take it in high school at all or?
No, no. Okay.
Hmm. Okay. Well, we'll be good. Do you have Petrushka? Do you have Petrushka or what do you have?
I have an Indian lady, Uma Iyer.
I don't know. Do you understand her?
Yeah,
Yeah.
yeah.
Okay, that's good. Where is my thingamajig? Gotta go here. And I want to view. I should probably open the door. Oh yeah, please sign here. Oh yeah, Jen. How are you feeling about calorimetry? You're getting it? That's good. Yeah, it's really formulaic when you get down to the stuff about it. Um, but yeah, today I was going to do like a group thing where like you and like I'll put you guys into groups and then you guys just answer the questions instead of like because you guys don't collaborate. I say collaborate, but then everyone just does things on their own, you know? But like, yeah. Um, we'll see if we have enough people for that. But that's good that you're getting calorimetry. It's a good concept to know, and it's probably going to be on the MCAT. Probably will be. I don't know yet. Um, anyone on Zoom? No one's on Zoom. Thank you. Mhm, mhm. Callipy versus calorimetry. Hmm. Do you remember Hess's law, Arlene? Okay. It's like this stuff where you like flip the reactions and
Oh, I actually love doing that stuff.
yeah, they're gonna get up to that tomorrow. And that'll be fun to do.
Wait, are you on Zoom yet?
I am on Zoom. No one joins on Zoom because I'm really bad at Zoom.
Oh, it's so cute, actually.
Yeah, I'm not really the best at engaging people on Zoom, so then no one comes on Zoom.
It can't be that bad.
No, it's pretty bad. Hey, Devinder, how are you? Hi. Hello, hello. How you doing? He's fine, he's fine, he's fine. Well, how's everything going? Yeah, okay. Will you take one of these? Not yet. Okay. I'll like just quickly go over everything and then I'll give you guys the thing. Yeah. Are you guys like understanding calorimetry and stuff?
I think I just need more practice. Because it's like I have to do the problems to really understand what's going on. So
Yeah, that's true. That's very true. Yeah. You guys remember doing this in like high school chem?
to be honest with you, no.
No, not at all. Damn.
I remember doing the universal gas constant, that I remember.
You didn't take AP.
What do you mean universal gas constant in high school Regents chem?
Yeah.
Really?
We have to find it out on our own.
What is the universal gas constant?
0.0821. I forget the unit, but
Oh, you have to figure that out?
I swear that was a lab.
Oh, it was a lab? Okay.
Yeah.
Maybe that, yeah, I can see that. Oh, that's the wrong
I
screen.
do not remember anything about calorimetry though.
Mhm. Okay. Okay. Let's see. Hello, how are you guys?
Hi.
Chilling. Please sign the attendance sheet. Okay.
I have two like specific questions from the act on that.
Oh, about the active?
Yeah.
Okay. We'll move to that.
Well, it's like things that we learned, like,
Yeah, that's fine. I'm not here to teach new stuff.
Can you refer like an NLP? Yeah, I wasn't
We
there.
didn't really like fully go over that.
Yeah, we did like one round.
Yeah, we didn't really go fully into that yet, so.
Okay, so then what about Michelle, you might with the catalog, the like one with the bomb?
About mama, yeah, we can go over that too.
No. 36. We need to do my questions in that.
Okay, guys, hi. Welcome, hey, please sign. So some of your questions about the bomb stuff versus, so with like the bomb things. Let's see this.
Wait, before you do that,
Yeah,
can you do the
good question?
the active?
Yeah, what's the active question?
There's two, I was like,
Can I have your iPad? I can challenge the whole class to do it.
so it's this one, I already did it, like, I don't know.
Okay, yeah, everyone didn't really.
And the one after this.
Okay, so I'm gonna pose this question to everyone, okay? So this question is that there is 1 gram of a sample, right? Of an unknown sample that you have, unknown. And it's combusted, right, with oxygen, and it yields 2.7 or 2.579 grams of carbon dioxide and 0.6536 grams of H2O. So some combustion, right, with oxygen forms this. All right. So the question is, what's the empirical formula of this unknown organic molecule or compounds? So that's the question. So can anyone tell me, like walk me through what you would probably do with this?
I know that you have to like find the carbon and the hydrogen. Like, and that's the carbon.
Yeah. So I think one, like the most important step in anything is to write out what's like the reaction, right? What's actually happening. So you have some unknown organic compound. It says here that it has, sorry, I first should have said that it has carbon, hydrogen, and oxygen. All right, so it has carbon, hydrogen, and oxygen. And then you're making carbon dioxide and you're making H2O. So the first thing to do, hello, please sign right here. The first thing you would want to do is you would want to write the reaction out. So let's do that. So this thing has CH and O. Let's just put these are just variables, right? In place of the numbers because you're trying to find out the empirical formula, right? Right, it's reacting with some amount of oxygen to form this amount of carbon dioxide and this amount of H2O, right? So the amount of moles for this, right, is producing this amount of mole of carbon and this amount of mole of H2O, all right? So the first thing you want to do is you want to take these values and convert them to moles, all right? Because we're trying to find the moles of carbon and the moles of hydrogen. And basically, all the moles of carbon from here are directly coming from this. All the moles of hydrogen are definitely directly coming from this, all right? So, right, so the way you would start this out is you do 2.579 grams of CO2, right, times 1 mole of CO2 over what's the molar mass of carbon dioxide? Anyone know? Yeah, it is good. Like you keep doing this stuff, you memorize it, right? So that's the molar mass of carbon dioxide, right? And then for every 1 mole of carbon dioxide, how many moles of carbon are in carbon dioxide? Yeah, 1 mole, right? So 1 mole of C over 1 mole of CO2. All right, and you get some amount of moles of carbon. All right, so that's important. We're gonna need that. And like
Are we
likewise,
finding moles or are we finding grams?
you can, that's actually, we have to find grams first. You have to have the mole of carbon and you also have to have the grams of carbon. So I'm just gonna leave that for right now. With the water, can anyone walk me through how to do that?
So you put the grams,
Yeah, put the grams of water, yeah.
by 1 mole of H2O over the molar mass.
So what is the molar mass? Can anyone tell me what that is? Water?
18.015.
Yeah, 18.015. For these kind of questions, I'm gonna give you guys a little thing, like, you don't really need to be super exact because it's an empirical formula thing, so it's usually gonna just, like, the final answer is gonna be close to the answer, or whatever, right? So times for, now what are you gonna times it by? Anyone like to walk me through this stuff? So this is H2O. And then what's on the top? 2 moles of H, right? So this will give you the moles of hydrogen that's produced. So if any of you guys can like calculate that really quickly for me, I'm just gonna get my calculator.
I don't wanna.
5. Sorry, guys. I'm really bad at handwriting. That's a 5. 6, 5, 6. 1/18.015. 2. All right, so the top one I got 0.05 86 around there, right? And the bottom one, let me see if I can do this right. Yeah. Right. Okay, so this is H by the way. This one I got 0.0726. Right? Everyone got that? Everyone chill with that? Good. Alright. So now this is the amount of moles of carbon that's produced. But that doesn't really help us in this step of the problem because we still don't know the moles of oxygen, right? So what we actually need to do is we need to convert these moles to grams. And the reason why we're going to do that is because the mass is always going to be, hey, Joanna, the mass of, look, it's a question that we were working on. The mass of mass is always going to be the same, right? If you're reacting 1 gram of one substance, there's going to be some 1 gram of the next substance that you're making, right? Regardless of if it's carbon or whatever, there needs to be 1 gram of that substance, right? And so because of that, what we're going to do is we're going to actually, because we know that this is the moles of carbon from this compound, right? This is the moles of hydrogen from this compound. So we can actually take this and make these into grams to figure out the amount of oxygen from the total. So how will we take these moles and make them grams? Anyone like to tell me that step? Yeah.
Just convert molar mass.
Yeah. So 1 mole of carbon, right? This is on the periodic table. Make sure you print it out so you can be comfortable with these values. This one would be 1.008 grams, right? Over 1 mole of H. Let me just see if there's anyone on Zoom. Oh, Matthew's on Zoom. Hey, Matthew, I hope you're seeing things. Okay. Anyways, all right, so can anyone tell me what those values are? Or do them in a calculator. Don't wait for me to do them. You want to be very fluent with the calculator. And what do you guys get?
Let's say like that. Yeah, 0.70386.
Okay, so I'm just gonna put 0.704, and then what you got on the bottom?
0.07.
Okay, I'm just gonna do that. Okay, so what you actually found is you found the amount of carbon that's being reacted from the compound, right? And you found the amount of hydrogen, right? So technically, what you're actually seeing is this is the amount of carbon within that's kind of within the compound, right? And you're given the total, so now all you have to do is subtract it, right? Subtract the total from the parts, right? So 0.000 grams, right? Minus 0.704 minus 0.0731. So you just take those values and subtract it by 1. So 1 minus boop minus boop. And I got 0.222 or 223 grams of oxygen. Is that what you guys got?
I have a question.
Hmm?
You took the 1 and subtracted it by both of those added together?
Mhm.
That's the mass of this.
Yeah, maybe I should do that so that you guys. I added these 2 values and subtracted it by the total. Because this is the amount of carbon, this is the amount of hydrogen. If you add those 2 values together and subtract it by the total, you'll get the mass of the oxygen that's being reacted. In that 1 gram thing. All right. And then you get. So this is the what's it called? This is the grams of oxygen, right? So now we want to convert these to moles of oxygen. So what do we need to do? What's the next step for that?
Divide by 1. Wait, is it technically?
Yeah.
Molar mass.
Divide by the mole mass?
No, the molar mass on the bottom and then.
Mhm.
mole.
Yeah, that's what I'm saying.
Yeah, that's what she's saying. So 1 mole over 15.99, right? It's only one oxygen. So that's what you're gonna use. And 0.223 divided by 15.999. Okay. And I got something around 0.013 moles of oxygen. So now this is now back to module 7, right? Empirical or module 6. Wow, you guys are really speeding along. So now what you want to do is you want to divide this by the small amount of moles. It would be oxygen in this case because this is the smallest amount of moles. And then yeah, you see the answer from there. So let's do
Wait, so
that.
you take the amount of oxygen divided by for each of them, because it's.
You take the lowest one.
Yeah.
So yeah, the one with oxygen is the lowest one in this case, so divide it by that, and then you'll get the answer. All right, does anyone else have questions about this? Just any other questions, comments, concerns? Okay. Yeah, this is a tricky question. There'll probably be like maybe one question like this or two questions on the test. I doubt you would put more than like 2 or 3, probably less than that.
The next one.
Yeah, I'll do it. What's the answer? So 1, 2, 7. I'm just gonna find the answer really quickly. 0.139. Okay. Oh, this one would be about 5.22, and then 0.0586 divided by 0.0139. And that would be around 4.2. So technically, you would probably multiply this by 5. And you'd get a value of C 4.2 times.
But how do you know you're multiplying it then?
Because you see how these are 4.2 and 5.2-ish, right? So like that shows you, right, that because they're because it's like in like 1/5, like you want to multiply it by 5 to get a whole number. So it would be what's it called? This one would be 21. Hydrogen would be 5.22 times 5 is 26, and then oxygen would be 5. So got the answer for this. It's like now.
Oh. What is it, 21, 26, 29?
Yeah,
Yeah.
there you go.
Okay, this is.
Okay. All right, so this question, it deals with vitamin C, an antioxidant. And it has the combustion data of carbon dioxide and water, and it tells you the molar mass between 150, the molar mass is between 150 and 220 grams per mole. Okay. Is everyone chilling? Everyone good? Okay. So this one's vitamin C. So vitamin C, this is actually something that haunts me. Because there's a question like this on my oral test and I got it wrong. It made me really sad. Vitamin C, absorbic acid. Yeah. Anyways, so 10 grams of vitamin C, right, is reacted and you're forming 14.99 grams of, it's combusted, right? So with oxygen, right? So you're getting 14.99 grams of CO2 and you're getting 4.092 grams of H2O. All right. And they're saying to determine the molar mass this time. And it's between somewhere around 150 to 220 grams of moles. Okay. So basically it's the same setup as the last problem. So yeah, would anyone like to try to do it on the board? Same problem, same setup as the last time. Okay. I would just like to try it. The question? Question is down right there.
It says determine the molar mass of the compound.
Yeah, it says.
If it's between that.
Yeah, so, sorry, let me write that better. Determine
The molar mass.
Molar.
Between
mass
150 and 220 grams.
between 150 and 220 grams per mole. Per mole. Okay, so that's the question. To determine the mass, you're given this amount, it combusts. Do you see how, like, I just want to say, like, most of these questions have like a lot of fluff in it. Like, this is what's happening, right? Like, yeah, it's good to just assume what's happening. So, yeah, would anyone like to try this on the board? Joanna, you made eye contact with me. I'm gonna pull you up here. Come on, come on, come on. Don't let me be the only one doing something. It's good to actively participate, right? Okay, so try this problem. Yeah, sure, you can pause. Here you go. Try that. Let me just go back here.
You're doing all what we did just then, but then adding it up to find the mass.
Yeah, so basically what we're gonna do for this problem is we're gonna find the empirical formula of vitamin C. And then from there, we're gonna take that empirical formula, find the molar mass of that empirical formula, and then divide it by the
I think just find the molar mass.
Do you have a better mark than this?
I don't know if it's better. Yeah, so we're gonna take the empirical formula, right? We're gonna get some like low number ratio, right? And then find the molar mass of that. And then from there, we're gonna see like, oh, what number in between that range would perfectly fit with that. You'll see it. Thank you. Thank you. The screen is sharing for you.
Vitamin C composed of.
Composed of carbon, hydrogen, and oxygen. Okay, that's what it says. The combustion forms carbon dioxide and water. No. It contains carbon, hydrogen, and oxygen. Can I see the question, really?
You better wash your hair tonight.
You guys have any Thanksgiving plans? Oh, no. Actually, maybe. Maybe. Yes, it's important to make sure you're very fluent in doing this math. Yes, yeah.
You're only.
Is that marker better?
Oh, way better, yeah.
Oh, yeah?
Can I write so far?
I don't know. You have my graphic calculator.
How is that gonna go? Just the concept itself, like, I mean, multiplying the correct things, or am I missing something? I feel like I'm missing something.
No, you're doing it fine. The only thing that I would add when I would do the work is to add the one, like it's still multiplying by one, so you tell. You're fine, you're fine. The moles of carbon equal the moles of carbon dioxide, yes.
What is it, 18 or something?
Yeah, 18.015.
Wait, but how come she put 12.011 grams of CO2?
Oh, she made a little,
Shoot, I made a
little
mistake.
mistake.
Okay.
Good catch, yes, yes, you were right. Joanna is wrong.
Oh, man.
As a joke.
Oh.
Okay, anyways. I hope you're doing fine, Matthew. How is everything?
Oh, there's phones.
Oh, you said great. Thanks, Matthew. I appreciate your live feedback. Oof.
Are you gonna be the SI for next semester?
Next semester I will be, but I won't do Zoom because I'm really bad at it. I'll do it at a better time. It'll be probably 12:30 to 2. Mondays and Wednesdays.
That's not.
If you have lab, you can just come after the lab. I think everyone is free before that. It's just that if they have a lab.
One day we're free, so,
Okay.
and Wednesday we're free.
Yeah.
Oh,
And then
yeah,
it's time
exactly.
for-
Yeah.
See, I told you right when you're
Yeah.
doing it.
So the reason why I really emphasized that like you guys should know how to like do the math problems because next semester is a lot of math. And like that's why like it doesn't leave, you know, so like it's important to know how to do this stuff.
Never wanna look at it.
So much now. You're the best. Oh,
At least there's no more count.
no, I'm talking to myself.
Calc is better than me.
Yeah, it is.
In that class, yeah, you could just teach it to yourself.
That is.
What are you doing?
Looks like you're doing it right. I believe in you. What are you doing now? Why'd you divide everything by 0.34?
Cause this is like the moles of carbon and then.
You made a little mistake. You made a mistake. You
Told
need to figure out the moles of oxygen before you do that. You don't have it.
I don't have it, okay.
So I'll take
So what am I
over.
supposed to do?
It's okay.
No, it's fine.
Oh wait,
Tell
no,
me what
you
to do.
actually, yeah, do it. So what you can do, what you need to do is you need to convert these moles to grams.
Oh, right.
Yes, so. Yeah. Yes. So, yeah, just like the last. Yeah, how you guys doing? I don't know. You think I can just like look at a question and know the answer? I assume. Yes, that is C3H1. How are you guys doing? Are you doing good, girl? You doing this question?
It's like the same thing with different numbers.
I see, yeah, he does that a lot. That's one of the things. I'm doing this stuff.
Wait, I have a
Where do you
question.
grab me from?
I have a question.
What's that?
Is 1.008 the amount of grams per one mole?
Hydrogen, yep. So, yeah, I mean,
If
like,
there's two hydrogens, you don't need to double.
no, you don't need to double it, only because, yeah, you're already doubling it by doing 2 moles of hydrogen. So, if you were to do the molar mass of 2 hydrogens, you don't need, you wouldn't double, you actually are doubling it by doing, like, for every 1 mole of water, you're making 2 moles. Yeah.
So then when you find that, then what do I do? Then I find the amount for oxygen.
Yeah, so what you do is you find the grams.
Oh, wait, I add these two.
Yeah, and then subtract by the total. I don't know. It looks like it's right.
Like, this is kind of weird, but I just kind of.
Yeah, that's fine. Then you find the moles.
Wait, and then what do I divide it by? Because it says it's between 175 and it's between these two amounts.
So did you find the empirical formula? So you want to first find the empirical formula. So yeah, so do once you find the mole of oxygen, and you do whatever for the empirical formula. Then
Right, okay.
okay, so yeah.
Did I divide?
Yeah, so now you now you divide.
Yeah.
That's a little interesting. It's carbon. Hmm. Hmm. What's up?
And then what do you do from there? Find them here.
And now you want to find the more elastic empirical formula.
That's what
That's what you got? E17H018.
I, this
What'd you
is more fun.
Where's the moles of oxygen?
Wait, but what do I subtract it by? One?
Wait, so,
I added it.
yeah, you added it,
And what do I subtract it by?
you subtracted by the total, which is 1.
Alright, I think I found something.
1 gram.
Is it this? You already find the answer for it, or?
Devinder found the answer and that's the answer he got, so I trust both of you guys.
It was 02, not 03.
Oh, two?
I was gonna tell you the mistake that I
Yikes.
made. What
Wait,
I did wrong.
I don't know, maybe, okay, let's see,
You got C 1.5, right? Before we multiplied,
What?
when you
There was
got,
no 1.5 anywhere here.
I'm saying when you got your final answer before you multiplied it to get that.
This looks like, right? That's all right.
But then the math is not, oh, that's the.
4.34 times 12.011. That looks right. Yeah. 4.5 times. Okay. Plus. And minus this. That's. Calculating 51. That's. Comes less.
Am I wrong, am I right? What the-
Sure, let me think about it just for a second. 14.99 divided by 4. Divided by 44. That's a. See. Is that right? Wait, let's see, is that an answer choice?
There's
63.
no answer to it.
So you're putting a min.
Oh, yeah. Okay, then try, put the molar mass, find the molar
Oh, of
mass.
this?
Yeah, find the molar mass, it looks like it's right.
Sure, that's.
Are you leaving
It's 4 plus, well, times 3, times 6. 9 plus 6 is times 3. That's that.
Very
Well, that's 40.
52.
No, it's 80.
No.
Yeah, it's 80. Right?
So now times that by 2 because it's in between 150 and 220. Because if you had something that's great,
Times what, this or this?
times the molar mass by 2.
Okay. 1, 7. Right?
Yeah, that's the answer. So it has to be 176. So the correct molar mass, the correct thing would be C6H8O6. Yeah.
Is that what you got?
I might have done something wrong with my oxygen, because I got the first two parts right, but I got 02. So I multiplied my answer by 3. But we'll see.
So. That answer's right. So,
Wasn't one of my three.
well, actually, you should probably do the exact size. So carbon is
This is round to 460.
around to 446, so. Yeah, let me just get my calculator. So the correct
Then yours 10.
12.011 times 3 plus 4 times 1.008 plus it's 3 times 15.999. Nice, times 2. So I got molar mass of 176.92.
Correct.
Nice, let's go. I still have my job. That's good. So you got.
I did something.
You did something wrong. Good job, Joanna. I appreciate you doing things under pressure. That is great. That is great. Every time you take a test, you're gonna be under pressure. So it's good to be under pressure when the stakes are low. So that you build it up. But when you take the test, because test anxiety is a real thing. The real thing indeed. All right. Did that help, Emma?
Yeah.
Yeah, okay, that's good. Okay, so anyways, I'm just gonna quickly go through whatever happened in class and then we'll get started with our worksheet. So. Calorimetry. Calorimetry again, right? It's the study of how energy is moving in a thing, right? Calor, right, in Spanish is like hot. That's what how I think of it. But he likes to use that word for something, I don't know. So calorimetry cups, like the coffee cups, what's happening in the coffee cup is like you got a cup, right? And there's water in here. And what's happening is some reactions happening in this water. And there's gonna be like some thermometer or whatever, right? And what's happening is the reaction is either absorbing heat or releasing heat. And what's gonna happen is the temperature is gonna record it by either showing that it's like the temperature is rising or the temperature is lowering. If the temperature is rising, that means the reaction is exothermic. So that's important to know. If the temperature is lowering, that means that reaction absorbing energy because it's taking the heat, it's taking it. I have a little bit of a challenging question for you guys. This is just a random question. When you guys break bonds, are you absorbing heat or are you releasing?
Releasing.
Absorbing. Why?
I told you that.
If you were to break a pencil, right, are you absorbing heat when you break the pencil or releasing heat when you break the pencil? If you were trying to break the pencil apart, like bend it. Absorb? Yeah, you're putting energy into the pencil to break it.
That's why it's barf. Break, absorb, release, form. Or was
Oh.
it release something?
Yeah, that's a good way to think about it. Yeah, management BART is, I guess that's a way to, I didn't know that was an acronym. That's crazy.
Chemistry.
Yeah, so that's basically how it is with, oh wait, you don't see that. Okay. Yeah, and then
Problem.
the bomb calorimeter.
Wait, let me see.
So I just want to explain something with the bomb calorimeter. So the bomb calorimeter, what's gonna happen with this, it's a little different than the coffee one. Because the bomb calorimeter, you're dealing with two things that are absorbing energy. You're dealing with the actual bomb itself, right? You're dealing with the actual bomb itself. And you're dealing with the water, right? Both these things are actually absorbing the reaction that's occurring, right? So the heat is going into both of these. Okay, and so actually I asked on the recent last session's thing, like a question about the bomb calorimeter, about like finding the calories of steak and whatnot. And all you have to do is you have to find out the Q bomb and the Q water because it equals this. So Q bomb, Q water equals Q reaction. So yeah, so that's kind of how you are supposed to do that. Q represents joules or whatever energy unit I'm referring to. So yeah, that's usually how bomb calorimeters work. So there's gonna be definitely a question like this on your test, so it's important to know that.
What? It's bomb plus water.
Yeah, it's the
Do the sample problem.
sample problem? Yeah, sure. Okay, so this question. All right, 5 grams of sucrose is burned in a bomb. The temperature of the calor. What's that?
It's not there though.
What do you mean?
Like, are you gonna put the problem there or are you gonna?
Oh, yes, okay. So yeah, 5 grams of the thing is thing, right? Okay, it raises from 28.3.8 to 42.7, right? The calorimeter contains 775 milliliters of water, and the bomb itself has the heat capacity of 893 joules, whatever, right? Blah, 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 blah. What is the heat production, like, produced by a combustion of this sucrose sample? All right, so I know we did this in class, but it's still good to keep doing these kind of problems, only because the formula is all the same, right? You can't really get super complicated with this unless you add a bit more words. The problem solving of these bond questions are always gonna be the same, where it's gonna be trying to figure out the Q of the bomb and the Q of the water, right? So let's just get into that real quick. So we know that there's a change in temperature from 42.7, that's the final, right? And 23.8 degrees Celsius from the reaction, right? The initial is 23.8. This is gonna be the delta T, right? And we also know that the heat capacity for the bomb, I'll do that, bomb. Heat capacity of the bomb is 893 joules over Celsius, okay? We also know the specific heat capacity of water, which you're gonna memorize and it's on your reference table. It's gonna be 4.184 joules over grams degrees Celsius. That's the specific heat capacity. What the specific heat capacity means, and I don't think he's ever gonna ask you this, but it's good to know what it means. It means that for every 1 gram of water, it'll take 4.184 joules of energy to increase that 1 gram up 1 degree Celsius. That's what's happening. So it's a good thing to know. So with this information 9, we also have the grams of water. What is the grams of water? Would anyone like to tell me what that is? Yeah, Devinder?
So times 5.
Yes, we actually have the grams of water. And the reason why we're able to do that is because the density of water is one, right? So for every 1 milliliter of substance, there's 1 gram of water. So it's good to know. So this is the gram of water. So I just listed out all the terms we have. And so the big thing that you need to know about this is that in order to figure out the total heat that's being produced in this reaction, you actually need to add up both the energy that's absorbed by the bomb and the energy that is absorbed by the water. Because everything in the environment is absorbing that heat, right? From the combustion of sucrose. So it would be Q of sucrose, right? Equals Q of bomb plus Q of water. Okay, so Emma, would you like to try this? It's okay. It's okay. That's what you're here for. To learn. Michelle, would you like to try?
What do you want me to?
Question.
The Q bomb and Q water to do like to solve one of these.
For Q bomb,
Mhm.
you take the milliliter, make it into gram. Right, so 775 milliliters.
Finding the Q water right now. yeah.
Okay, so you do that for the water,
Mhm.
so,
So 755 grams. Alright, what's the formula that we're gonna use? Yeah, Q equals M. I'm glad that's catching on. My 32T did not catch on, but Q equals M catches on. Okay.
okay, so the mass is 775.
Mhm.
The V is the specific heat, 4.1.
Mhm.
Gauge and C is gonna be the 18.9 degrees Celsius from the 42.7 minus 20.
It's 18.9. All right, cool. And then yeah, let's find this Q water. So what's the Q water? Oh, you didn't capture it? Oh.
No, I.
Hey, that's good. That's the most important thing to do. Nice, good. 4.184. 18.9. Really important that you guys make sure you circle this.
61,285.
You put 775 and you put 7.5.
Oh, yeah, I was getting a little confused. My bad. Yes. Yes, okay.
Wait,
So,
for these bomb questions, are they always gonna be bomb plus water?
yes.
Oh,
What the
Yes.
heck is a bomb?
The bomb is the thing that's being, so like, imagine,
Burned in a bomb.
right? There's like, this is the bomb. This is the bomb, right? Okay, there's water like
But
in.
why is it called a bomb?
And
It's just.
no, there's water in this container, and then this is where the reaction's occurring. So the reaction's releasing heat into everything. So this is water, it's releasing heat, it just releases heat, right? So in a closed system, the only thing that's absorbing heat is the water and the bomb. So that's why. Anyways, so yeah, I also got 61 something. So 61 285 joules. Okay. Did everyone get this? 61, yeah, good, very good. So then now what you need to do is you need to find the Q bomb. And this one's a little bit more complicated, but it's actually not, because it's actually easier because you only have to multiply two numbers.
Why? You only have to
Because
do.
you.
Heat capacity.
You don't have the heat, well,
We
it tells
do
you the heat
8,
capacity,
9.
but you don't have the gram.
Yeah, there's no grams, right?
So you could just take it out.
Because there's actually a formula that you could know, or you could just know dimensional analysis. And so the formula is heat capacity, right? Equals Q over delta T. Right? So we're trying to figure out Q of bomb. We have the heat capacity and we have the delta T. So all you can do is take the delta T and multiply it by heat capacity. And
Q.
yeah, to find Q bomb. So the heat capacity of the bomb is 893 joules over Celsius, right? The delta T would be 18.9 degrees Celsius. This cancels out and you're left with joules. So you don't even need to memorize the formula because you can just use dimensional analysis. And that will expedite you from needing to memorize things. But yeah, so I got 16,000. something, right?
I hate
Is
that.
that what you guys got?
I know.
You guys get this? Yeah, okay, and then you just add these two values, so you just boom, 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 boom.
Answer, I'm putting kilojoule.
Oh, it doesn't put in kilojoules?
I don't know, but he said that.
Oh, yeah, I mean, you could do that in kilojoules, so this is 78,162 something, right? I don't really do sig figs, you don't need to do sig figs, because your test is multiple choice. It's multiple choice, so you don't need to do sig figs, that's a very nice thing. Okay, so joules, right? To convert to kilojoules, you need to do, how many kilojoules is in one joule? Or how many joules is in one kilojoule?
1,000.
Yes, right, so for every 1 kilojoule, there's 1,000
You're right.
joules, so you really divide the joules by 1,000 to get the kilojoules. So the right answer would be 78.2 kilojoules, why not? Okay? Alright, everyone chilling with that? And understand? Alright, sounds like a plan,
I
Stan.
just want to-
Okay?
Can you just like review it SLP a little bit, cause I missed that.
Yeah, yeah, that's part of the schedule, so.
Same thing, limiting reaction. And then you just take the
Yeah.
energy they give you and divide it.
So you guys haven't learned the bulk of this yet? Because yeah, this goes into a lot more things like Hess's law, which you guys are gonna learn tomorrow. So that's a lot pretty fun. But you guys will see. I mean, you guys, I say it's fun, but you guys might say it's annoying and frustrating and stuff, so. It is what it is. So yeah, basically what it means is that heat of products and heat of reactants, right, equal heat of reaction. I don't know if you guys saw what he was doing in class. He was just showing like a energy diagram of like products over reactants. I don't know if you guys remember this do you guys remember this in high school where you guys did,
Yes.
right? So what that means is this is the heat enthalpy. This is the heat enthalpy right here. So this is delta H, right? And that's what's showing right there. So in these reactions, right? If there was a question that asked about, oh, what's the enthalpy if you're given this, right? All you have to do is take the difference between the products minus reactants, right? So in this case, delta H would be negative because it's exothermic. It's going from high to low, so it's exothermic. If it's like, right, it would be positive, right? Products minus reactants, there's a positive value like that. So delta H is positive. Okay, so that's a very quick thing to say about that. It's really kind of he was trying to explain this. I really wish he like. If he was explaining it like this, I would like him to explain it with Hess's law, but he didn't explain that with Hess's law, so he just did this question. So this question is. It's basically, yeah, this question is not really. It's not really what he was explaining in class, because they're kind of two different ideas right now. What this is this kind of more of like the stuff we learned like in the 9.2. So like, yeah, but just like limiting reagent, right? So, do you want me to go over this problem? Or?
Yeah, I missed it, so I just wanna see one how to do it.
Okay, would anyone like to do it on the board? Anyone?
Just.
Okay, all right, okay, so
I understand.
what's the first step to any of these problems? Can anyone tell me?
Right out your equation.
Write out the equation. So what's the equation that's happening here?
Yeah, Fe solid plus CO2 gas makes FeCO2 solid.
Yes. So, yeah, Fe. Okay, so it's 1 mole, 1 mole, 1 mole. Everything's balanced. Okay, so what you need to do first is you need to do limiting reagents. So there's F 2.84 moles and 3.60 moles or grams of Cl2. All right. Yeah, you guys want to do the limiting reagent? Who wants to do it?
Wait, what are you trying to find? Oh, and the moles.
We're trying to figure out.
FeCl2?
We're trying to figure out how many moles of FeCl2 is actually made. And to do that, we have to do limiting reagents with the stuff. So
FeNCO2. And then you
So you're
take the
getting, okay,
smallest
I think I
one
could
and
do
divide it
Yeah?
by the
I
amount of.
think-
let's go. You got this. Come on. You got this. I believe in you.
Okay, but I don't know any of what them as.
It's okay. So Iron, I think it's 55.84 or 5. Let me look that up. AP Chem reference table,
right there.
54.845.
54.
55.845.
Okay.
Oh, Michelle.
That's why.
I was right.
And this is a great hat.
And then fluorine would be like 70.1.
Wait, I'm not.
Oh,
there
sorry,
yet.
sorry.
Okay, so you put 1 mole. Okay. And we're getting the moles, right?
Yeah,
So that's just equal.
Yeah.
And then the one is 1. What is this one?
That one would be like, I'll do the math for this
So
one.
we have to multiply by 2.
35.4 times 2. Yeah, 70.9.
Okay, so it's just like that.
Yes.
Okay, I don't have like.
So, I mean, I can tell you to you. So the top one would be 1/55.84. So 8445. Okay. And then the bottom one would be 70. Okay, so what we can see here is that the top one is 0.0509.
0.0509.
09, right? And the bottom one is 0.0401. So which one is the living reagent?
So this one.
Yes, all right. So now all you need to do with this question, it's actually very simple, right? So they're asking what's the enthalpy change for 1 mole of this reaction reacting? So what you need to do is, what that means is for every 1 mole of that, of iron 2 chloride being produced, right? How much energy is being released, right? And so it's telling you the amount of energy that's being released with that amount of stuff. And you found the moles of this. So now all you need to do is just put the energy over the moles that you got. So the right answer would be 17.2 kilojoules divided by 0.0401 mole.
Wait. You're dividing it by or you're dividing the 17 point whatever by that.
Because then this will give you the amount of energy released per 1 mole of iron 2 chloride. And yeah, so it's actually not super bad. It's just kind of an addition to the limiting reagents question that we've done in module 7. Yeah, okay. So I got all right, that's about right. 17.2 divided by number. So I got around 429 kilojoules per mole. Is that what you guys got? I do it wrong.
I think the CO2, it's still limiting reagent, but I think the mole number is wrong. 'Cause I got 0.050775.
Oh, I did something wrong in the calculator. That's not your fault, Emma. That's my fault. That's a good catch. Yes. So I did something wrong. You're right. So it would be 507. I multiplied this by 2.84. That's my fault. So yes, so 5.07. And then yeah, in class, I was wondering, in class you guys got something with 5. So the actual answer, sorry about that, would be 0.05. So the actual answer would be somewhere around 339 kilojoules per mole, right? All right, nice. Everyone's disappointed in me. All right, got it. It's okay.
Negative.
It would be negative, yeah, because it's releasing heat, right? So anytime you see something that's releasing heat, yeah, you can just say kilojoules is released. Or you can put negative in there. Doesn't really matter because it's multiple choice. Yeah, okay, give it up. Oh yeah, so that's basically all he went over with enthalpy. You guys are gonna go through more questions next week, and tomorrow about that. But yeah, so yeah, with that, I'd like to do our group activity. But yeah. So, yeah, are you leaving now?
Yeah, but can I take one of the papers so I can do it?
Yeah. Oh, yeah.
Yeah.
Alright. You're leaving as well?
No, I didn't get one of those.
Oh, yeah, so I was gonna give you all of these now. So, please take it, I'm gonna split you guys up into groups. And you guys are gonna do this, cause I want some collaboration, guys. Okay, so before you even look at it, stop looking at the minute. See you guys looking at it. Yeah, write your names first, that's the most important thing.
Thank you so much.
No problem, have a wonderful day. What's it called? Yeah, so we're gonna do this problem. We're gonna do these problems together. Alright, you guys are gonna kind of compete with each other. So how about you three guys and you three guys? You guys all come up and one guy gets one side, the other person gets the other side. Okay? And then you guys do the problems together. And then I watch. Okay? I'll be okay.
Versions of making us entertain you.
Yeah, exactly. I'm trying to build relationships too. It's not just chemistry, you know? I'm trying to make bonds out of you guys.
That one did not land.
So let me just import since. Yeah, so you guys have the thing. Wait, Devinder, you don't start yet. You have to work with your team.
I'm just writing out some stuff.
You need to work with your team, collaborate, and speak to you guys. Speak to each other. Okay. And I'll do the problem.
We collaborate. It's four problems. Can't you just do a separate problem?
I mean, you could do that too, but I want you guys to I want you guys to oh, what is that?
Yeah, I saw that
What
earlier.
the hell?
I don't know how it got in.
What the hell?
Where is it?
What is it?
Ooh.
Is it a bee?
It's a wasp.
I swear to God, bee wafts.
Ooh.
Why are you running away from it?
It's so big. It's so big.
A month ago, there
I
was
know.
like
What the
10 of
hell?
them-
It's November.
10 of them that surrounded me while I was
It's
eating
November,
lunch.
that means it's angry. Never mind, I'm running. See ya.
It's angry.
Cause wasps and bees in the I mean, not winter, I mean, in the fall, they're like crazy.
You know why they're crazy? Because their whole livelihood is screwed. What the hell? Okay, I'll keep an eye on it. You guys work. I'll protect you guys. If I get stung, it's this is my job as an SI.
Are you playing workers, Tom?
No.
Damn.
Was this part of your job description?
Oh dang, you might die in the light.
No, he won't. You think he will?
I don't know. He just went up there.
I'm pretty sure the protection over the light.
No, so you know why flies near the light? 'Cause all these bugs, they fly near the sun.
Can they stay up there?
What, in the sun?
Yeah, so they don't come near me, you know?
I don't
Just
know.
generally.
Guys, get up. Get up. Do it on the board.
They're not team players.
Yeah.
You guys are the small ones. You guys carry me.
Look at me, you're constantly like studying or whatever. It's always all the time
What?
studying in class.
No.
I couldn't think you involved.
I'm studying for bio. It made no difference. I still did.
What'd you get?
No, the second test I got 77. 98.
Oh, 98?
Yeah, that was
For
good.
bio? Wait, bio's grade came out?
Actually, you're like
The bio 2 test came out?
Yeah, that was like a week ago.
Oh, I didn't even know.
Yeah, the average was higher than the first one for some reason.
Really?
I don't know why.
It's probably people studying.
That's probably the highest grade on the first exam in the entire class, a 98.
Maybe, and then I
That's
dropped so
crazy.
much, so.
I only know one other guy who got like a 95.
What exactly do you like calculate involved in this reaction?
So evolved means like what's happening, like what is.
98, 97.
I'm only smart.
The Homali is crazy.
Oh.
Even my school, you know, like
What school did you guys go to?
Eric's.
Without
The vendor. What?
Is that in Long Island? or-
Yeah, Long Island. Nassau County. It's in
Nice.
New Hyde Park. You know where that is?
Oh, you know, I know what you mean.
Yeah, it is.
What'd you do?
It's not the place, so.
Oh, no. The vendor, you know Shivani?
Use those big brains of yours and stop yapping about other
You
things.
just said to start
Okay, sorry.
Molly, me. There's a lot of hair streets.
I see.
I'm gonna do the problems with you guys, so if I finish before you guys.
You get a prize?
If you guys finish before me, I'll get you guys something next session.
Well, depends what you're gonna get, like,
What do you want me to get?
Dunkin' Donuts.
You want me to bet? I'll get it.
bro, don't actually spend money on us, it's not.
I already spent money for your candy.
Okay, but candy's like cheap and they probably have a
Yeah.
sale for Halloween.
You think that was cheap?
Well.
You think
it's
I was
funny-
cheap?
Well, how many, what, 100 packs, 550 pack, how many do you buy?
About enough for everyone to eat after your chem test.
Why the hell would they keep bulking the thing?
Wait, the units is kg.
What, 15 bucks, 10 bucks?
Yeah,
Yeah.
that's $15 of my hard-earned money.
And Dunkin' Donuts is gonna be more expensive than that,
Okay,
so don't spend it.
Well, then don't beat me.
Limiting reaction.
Okay, cool, I'm standing here.
just beat me. Go beat me. If you beat me, then you win a prize.
So maybe we multiply this by this? Well, this isn't.
I mean,
Cause you have kilojoules over moles. So you just this just cancels out, and you just multiply these two. That's what I.
There's a little trick to number one that you guys might be forgetting.
What?
It's an acid-base reaction, right?
You realize it?
I don't know. I'm just saying, acid-base reaction. What's the first step to doing anything? Write the reaction, right?
Sure.
Yeah, I think so.
What is it? B H
You get.
H2.
HCl.
Is this? Do you happen to have a solubility table on you?
Aqueous? No. OH is.
Or can I just assume it's aqueous?
When you're doing a neutralization reaction, right? Does it matter?
No.
Neutralization reactions are just neutralization reactions
You
between
don't
acid and
have
base.
to write.
It's not an precipitation reaction.
Two of these, because that's two of these. That works.
Uh,
Otherwise, right?
why is it not?
Oh, wait, no.
Oh,
H
that's
two,
good.
so that's four.
Yeah, that works.
This. Yeah, or, yeah.
Oh, so we can't do this, right?
What was the heat involved?
So then.
Actually,
MCAT?
something like that, yeah.
MC does the.
Wait, so then what's this equation?
Isn't that like titration or something?
You said there was a trick, so I'm trying to use some random equation that has something to do with this.
That doesn't mean there's a,
How do you?
trick is,
Is this the trick?
no.
Okay, cool. Can I have an eraser? I'm not gonna use my hand.
Oh, I solved it. Catch.
Luke, I know you brought a ton of erasers.
Oh yeah, I have like 4 erasers. I just steal the erasers from the.
I know, I saw your bag.
I
what I'm
just
saying.
steal all the erasers from like the classes I'm in.
Let me see your work.
We didn't get anywhere, so you're not gonna get any farther.
Thank you.
Yeah.
I think we have to use the.
Yeah.
I actually don't know where to go.
Aw, babe, it's too hard of a question.
So
We'll
what,
just like continue.
you want the combined, so it's 150 milliliters?
I started off like this just to find the moles of each of the compounds. So,
Let's get the
C is
find the limiting.
814.
so this would be your limiting reactant.
Wait,
How do you
So, you have less moles of this.
Something,
But it's
right?
different.
You have to find that.
Yeah, we.
Oh,
have
you're
to
saying to
find-
convert it
It
over.
started at 0.5.
TF
A
minus.
mole of
No,
HCl.
that's part B.
What's the
Part
code?
A is calculate the heat involved in this reaction.
No, but I think we have to do part.
400 milliliters.
No, it's negative 118 kilojoules per mole, right? Because you have to find the amount of moles of the.
Cancel
You guys make me really proud. I like this. This is actually making me really happy. Okay, sorry, just.
Yeah, no, we have to find the
Keep going.
moles of the
Just keep going.
product,
So when we just convert from that to.
right? Okay, so
You get the moles already.
100 milliliters of that,
Point.
50 milliliters of that. You guys calculate it. I'm pretty sure 50 milliliters is the limiting reactant. Right. So just do the 50 milliliters divided by, what's BaOH two?
And what is it? Is it 1 mole of HCl per,
Yes.
or what?
Yeah.
Let me just look it up on my phone. Just BaOH.
The mole mass?
Let's do 1 mole BACl, just see where we go.
Yeah,
So it'd just be the same, so 0.1 mole. I'll do that one second. We convert this.
Sorry, guys, it's not really a trick if you don't realize it's a trick.
171.34.
What? Yeah.
Search it up.
No. Yeah.
Right, so this is
Oh, wait, but there's,
1.34
is it too better for this?
times
Molar mass, yeah.
Yes, it is.
we actually.
So this would actually be the exact same thing.
Okay, the vendor found out the little trick that wasn't really a trick.
How's it a trick?
It's not a trick,
I don't get it. How's it a trick?
it's not a trick, it's
Okay,
actually
so
fairly.
both are limiting reach, so that means the entire thing is dissolved. So you said
Cool.
That means it has to be solved.
So I get to do the math, so this.
So this
times
completely dissolved into that, so there's no limiting reactant.
From this to
How does
this.
that help?
Right, so wait, just one mole to
Um,
one mole, and it's 1 to 1.
It's
And
one,
next.
two, something.
Oh, I should probably tell Matthew. Matthew, just do the problem, do the worksheet, I don't know if you're still here.
I was just getting both in.
So that's how many.
Oh, he's still there.
But
Is your,
Q-
is this the test gonna be the hardest one? Yes, it is gonna be the hardest one. Yes.
just multiply this.
Good thing it's being dropped.
Because if this is the heat of the reaction, if it's a negative 118 kilojoules
Yeah.
per mole, it's just.
Drops, but it's not, it doesn't change like the.
What's the thing?
It doesn't change the test. Yeah. It doesn't change the test, yeah.
Yeah, you know this for the final.
Yes, you do need it out for the final test. Great.
The last test I got robbed 3%. I messed up. I wrote the packet
Mhm.
and then I wrote D, the answer sheet. So that was the
In the
best
reaction.
ever made in my
This
whole
thing.
life. No.
Yeah, it is what it is.
Alright, so then for B, we have to do. Final temperature of the reaction start at 25 degrees Celsius, so, yeah, we have to use.
Actually, it's not negative, right? Because he said that the sign doesn't matter.
Yeah.
Okay, well, whatever. So just do the math, yeah. Yeah, 150.
And when you just pull up a periodic table, quickly.
I got one. What do you want?
0.9. Just give me the mass of barium. I have CO2.
137.3.
X is 20.
Degrees, so we have to do.
Right? Degrees.
Final temperature.
The original temperature. Not sure, is it?
It's the final.
It's the final mass emission.
Oh, it's a final. Okay, well, whatever.
Uh,
It works either way.
E is.
Can you check? I'm pretty sure we're wrong because we have such a small difference.
Hmm?
It's like a 0.055 degree difference. Am I wrong or am I right?
Q is the, no, C is heat capacity.
I'm flipping it right now.
Yeah.
Faster than you though.
No, I mean, I do the problems, I know how to do them, but I didn't do. It's not.
He released, right?
It looks like it's fine, let's see if. Right.
Or it is.
So we have, do we wanna convert that to regular joules? I don't know, makes any sense. Alright, let's just write it out like this.
Where did you get the Q word?
Here,
How'd you get the Q?
like this.
Are we using Q or something?
Because we have to find the final,
Do we need it? We want
Where do you get 171.34?
worse.
That is the molar mass of BaOH2,
wait,
which I'm pretty sure is a limiting
wait, we
reactant.
don't even need it, do we need to use that?
No?
No,
Says
you
why
don't
don't we
use
use water then, because we know the specific heat of water. It's 4.184, I think that's on our
Reaction
table,
that's-
but.
To cancel out moles.
Right, so is there
Happy-
actually limiting
and
reagents
mass
happening?
of Water. We just,
Wait,
Figure out.
so you're saying we just need to find the moles of the limiting reactant to cancel out the
Yeah,
moles of this?
because yeah,
Okay.
for every mole of limiting reagent, that a mole reaction is occurring.
Oh,
Okay.
wait,
So then,
so that's what we did, no?
it would just be.
But is there limiting reagents in this
Pretty
question?
sure there
It's
is.
0.1 moles of water, because.
Considering that
If I
HCl weighs
replace
way less
this-
than BaOH2,
How does
and there's
weight-
less
Well,
How
BA.
does weight?
Like molar mass, whatever.
Even with this one, because
There's
we
no
said the
thing.
entire thing completely reacts,
It's all.
even if I replace this top one.
Okay, you just multiply milliliters times molar, you know?
Yeah, but how does mass have to do with that?
So you have 0.1 moles of water, so times.
That gives moles.
Yeah.
So we can use the math of water instead and have the answer.
Wait, it's still a limiting reagent or reactant,
Are you
right?
sure about that?
It's not a
It's
limiting reactant.
50 moles? Oh, never mind.
Yeah, because you also need to take into account the ratios.
Because I was stupid. My bad.
So they're actually all in equal
So
reactions.
what do I do now?
So now you just need to see, calculate whichever one.
It said,
So,
what's the ending temperature?
Okay, so the reaction is negative 118 kilojoules per mole. Yeah.
Starting.
yeah, but
Oh,
you need to
start
see
at
how to
25?
get from this specific amount.
Probably fix it out.
So Q is equal to 118.
Q is not equal to 118. Q is equal to the moles of the reaction that's happening times.
Converted this one.
I'm hungry, I'm tired.
I always finally
Yeah.
went first, but for some reason I felt like he did it
Should just go eat.
usual first.
Oh,
Cause like the final one.
So you put,
I always thought it was final.
That's what I thought.
is it final message? Because if the reaction's negative, right? Oh wait, probably is final message. We'll just try and see how far we get.
Alright, so I wasn't even thinking, that's the amount of moles.
I don't know how to do it.
Moles of BaOH2.
Hmm?
And so 50 moles. Is it 50 times negative 118? That?
Hmm?
Is it 50 times negative 118?
50 times 108. It's this amount of moles times.
Oh, wait, you have to convert to liters. My bad. 0.05.
Oh, I got this. I don't think that's right. I don't think that's right at all.
What did we do?
So I think we wrong. This, right? Because they're both equal, right?
That cannot have been the starting temperature.
5 mole reaction, right?
I mean,
And you multiply by the mole.
How is the final temperature that low?
It's reacting, that's the mole reaction occurring.
Because I converted this to joule.
Kilojoules of things that's coming out from the reaction.
And that's Q.
Yeah.
Okay.
Yeah. And then remember, kilojoules, not joules.
I could kill you.
No, I know, but then when you do math, MCAT, are you using
Okay.
kilojoules or joules?
Okay, you're right.
Right, so you have to convert kilojoules. to
I just
joules.
realized what you said was right, so this specific
I
key
just
does
looked
not
at
matter.
I just looked at the unions.
Yeah, so what was the specific key? It was like negative 118 kilojoules.
What the heck? What are you doing?
I don't know.
What are you doing?
I don't know.
What is, okay, all right, okay.
They're both.
Okay, I want everyone to sit down really quick.
Wait.
Okay, guys, we went over this in class. I just added a value to this. We found the, what's it called?
I got part A, not part B. That part B makes no sense.
Let's see this. We went over this, what's it called? Where do we go from here? We went, where is it? We did something.
It's still a very minor change in temperature. I'm confused.
Okay.
I'm just doing it wrong.
We did, so this question okay, all 4 of these questions that I got were like based off of the questions that we did in class. It's just a slightly different, right? Instead of asking about finding the kilojoules per mole, right? I gave you the kilojoules per mole and I asked you to find the final temperature, right? So very much the same process. It's just that I put in one unit and I'm asking you to find a different one, right? And then what is the amount of, that's essentially what is asked in part B, right? What is the amount of energy released per mole of reaction? So like, okay, so just keep that in mind, okay? So I should never erase that, that's mine. Sorry, I'm so sorry, okay, so with this question, alright, you're given 0.100 liters of HCl, right? And you're given can you guys see this?
Yeah.
Okay, 0.0. Ooh.
0.05.
Yeah, 0.05. Moles of, 0.0. moles of BaOH, right? 2. So this is taking in a lot of the stuff from module 7, right? Okay, so with this in mind, right, we take we use the molarity, right? So this is moles over liters, right? Times moles over liters, right? You get this, right? Whatever, what's the moles over liters? So this one's 1, they're both 1, yeah, they're both 1 mole, right? So they're both 1 mole, right? But the thing that you need to realize, okay, and this is really important, is in an acid-base reaction, the H and the OH need to react in equal amounts, right? And so that's the thing. Barium hydroxide has 2 OH minus moles, right? HCl only has 1, right? And so what's actually happening is the amount of this amount actually gets multiplied by 2, right? Because this is the amount of HCl and this is also the amount of H plus ions, hydronium ions, right? So this is what's it called? 0. What's it called? 0.1, right? Yeah, okay. And then this one, right? For every 1 mole of BaOH2, there's 2 moles of OH minus. That's becoming whatever, right? Okay. So what you see is they're actually equal amounts, right? That's the whole gist of this, right? 0.01, right? Everyone thinks it's 0.01. So this is the amount of moles that's actually given. And the thing, because they're equal amounts, it's not actually a limiting reagent question because they're equal amounts. And yeah, you can do this however else. You can also write the reaction to figure that out. But they're equal amounts. H plus and OH minus are equal amounts, so they react fully. So that means that this is the amount of roles of actual reaction that is being reacted in this reaction. So if you took, because the reaction at its core is just OH minus reacting with H plus, right? So with that in mind, you take this reaction, you take negative 118 kilojoules per mole reaction, right? And you multiply it by 0.1 moles of the thing that you have to find the kilojoules of thing evolved, or at least. So you should get 11.8 kilojoules, right? Okay. Okay, you guys chilling? That's salty. Yeah, okay. So what's it called? Yeah, so that's essentially like how you were to solve it, right? Because really what you want to find out is the moles of HCl reacting properly with the moles of BaOH2, right? And so technically, right, you need, in this reaction, you need for every 1 mole of this, you have 2 moles of OH minus reacting, right? And that's actually what's happening. And so like, even though that there's no coefficient here, there's still 2 OH minus, right? And that's why you need 2 HCl, right? So.
And how does that matter? You already balanced the equation.
No, I know. I'm saying that in the sense that like, I'm trying to see how it is. Every 1 mole of HCl. Another way to do this is to do 100 liters, right, of HCl, right? Times 100 moles over liters times 1 mole, 2 moles of HCl is over 1 mole of OH2. You know, 1. Mole. I have a different answer. Wait. Maybe it's right. Wait, okay, let me see this really simple. So they're supposed to be equal amounts. That's the bottom line.
But then which value do you use for multiplying by negative 118?
I'll make a good answer sheet. Well, the thing is that Um. Yeah, you would use the lowest one, only because even though, yeah, like technically. I should have done the answer before this. 0.05 times one. Yeah, you would actually do the one with BaOH minus OH2. So I just did a completely wrong thing here. This is not right. I'm bad. Sorry. So yeah, the reason why you would do BaOH2 minus is because it's actually the lowest coefficient, right? And so technically for every 1 mole of that reaction, 1 mole of barium hydroxide reacting, you're getting 1 mole of the whole reaction actually occur. And so, and yeah, so what's it called? Yeah, this just shows you that they're equal amounts. If I were to use the coefficients, right? So because they're equal amounts, they're reacting completely with each other, right? And so, yeah, which one would you use? So like there's 0.1 moles of HCl and there's 0.05 moles of BaOH2, but they react completely with each other, right? So you would actually use this one because this is the lowest one. I know that's kind of annoying. I'm sorry, guys. So then, yeah, from using this, you can go to the moles of reaction, which is 0.05 mole of BaOH2, right? And multiply that by the 118, negative 118 to get something. 118 divided by 0.05 or multiply by 5.9. So yeah, these guys actually got it right. That's why I was confused a little bit. Sorry, guys. So yeah, 5.09 like kilojoules, right, is being released. Okay. So the next thing that you need to do is you take this kilojoules and convert it to joules, right? Because with Q equals MCAT, what we're actually going to use is we're going to do just, yeah, Q equals MC delta T, right? And so the C value that you're going to have is 4.18 joules over grams divided times Celsius, right? So because it's grams times Celsius, right? This value, 5.9 kilojoules, needs to be turned into joules. And so how you do that? You multiply this by 1,000 joules over kilojoule, right? To cancel it out, right? 1 kilojoule has 1,000 kilojoules. So this actually is going to be one, two, great, like this. So there's actually this amount of joules
Where did you pull the 4.18 from?
in my brain. It's going to be on your reference table. That's the specific heat of water.
Or why would you use specific heat of water?
So this is the question that we did in class, right? The reason why you would use that is because even though this whole reaction's occurring, right? It's in aqueous, it's a water solution. So because of that, we can use the specific heat of water to figure this out. So that's where you guys are going wrong. You guys are a little confused about that. But we did a question like this in class where, yeah, we have a reaction like this, a acid-base reaction occurring. Because it's in aqueous, we use the specific heat of water. So that's all very important to know. That's like in the calorimetry cups, right? Even though like if the calorimetry cup increases in heat, right? That's because some reactions occur, but we still use 4.18, right? So what's it called? So you use the milliliters that you have. So in here it's 150 grams, right? Equals delta T, which is delta T here is, well, we don't know it, right? So it's F minus 25. And then here it's gonna be this 5900. Okay, joules. So when you do that, you get a pretty good number, 150 times 4.18. Okay, and then plus 25, and you'll get around 34.41 degrees Celsius. Okay. Sorry about the little confusion. I had a little bit of a brain fart for the first part of the question. But yeah. So, are there any questions with this stuff? Mhm. So yeah, just to clarify, because I was a little confused myself. 1 mole of a reaction means that the balanced reaction, this whole balanced reaction is actually occurring, right? 1 mole reaction means that 1 mole of barium hydroxide is being reacted with. 1 mole reaction means that 2 moles of HCl is being reacted with, right? 1 mole reaction means that this is being formed and this is being formed, right? So, like, I guess where I went wrong is, for whatever, right? So I think, yeah, where I went wrong with this is that, whatever, 1 mole per liter, right, times, so this is HCl, right? For every, how many moles of HCl is reacting in the reaction to make 1 mole of reaction? There would be 2 moles of HCl, right, for every 1 mole of reaction, right? And then you do the same thing here, right? 0.05 liters, right, times 1.00 mole per liter. How many moles of barium hydroxide react, right? 1 mole of barium hydroxide per 1 mole of reaction. All right. Sorry, I confused you guys, but I figured it out. So that's how that's how you would probably have to do this kind of question. Yeah. Bye. You guys chilling? What time is it? Is it late?
7 minutes.
7 minutes? Okay. You guys wanna do one more, or do you guys wanna pack up? I don't really have a preference, but I don't want you guys to stay too long.
I personally don't care. I don't know what everyone else wants.
You wanna do?
So no,
Do another one? Okay. I'm sorry about this question, but yeah, the next one should at least do. I shouldn't say that. You guys got this, okay? I believe in you, okay? Just do, yeah, try the next one quickly. And then, yeah, I'll do this one. And then, yeah.
Yeah, I gotta go.
I thought, we go. I don't think, see.
This is it. The individual.
Yeah. Need to write an equation, please. I'm trying. I don't think there's any reaction occurring.
Yeah,
What?
dude, do you not, are you guys not like awake in class?
No.
This is literally a question that you guys did in class. Except I give you a different thing. I'm like, I just been changing it up.
molar mass of sulfur, like
32.07.
Okay.
I think.
take your word for it.
Is that the molar mass of sulfur?
What do you for B?
I didn't finish it out. Wait, give me a second. I need to multiply it in the thing.
Wait, what'd you get for A?
A got 76.5.
Okay, so I got that right. What did I do wrong in B?
Oh, I didn't do.
You didn't get the same numbers.
446. Final temperature.
Insanely high. Let's put it that way.
Those are hot. Sorry, I can't make that shit. Okay. All right, you guys chilling with this? All right,
I got
you guys are
550.
confused? What's that? I got 74.65. Okay, so that's good.
Wait, what did you get for B?
What's it called? For B, I got 447.
I got 549.
Okay, it's not super bad. Okay, so, all right, so. Okay, a couple things. Actually, I just wanted to say that. Yeah, this reaction wouldn't happen in real life, technically speaking, right? Because if you think about it, if this temperature of water is 447 degrees or 500 degrees, it's quite high, so it's gonna evaporate, so it's not gonna actually happen. So the first thing that you need to do is you need to figure out what's happening in this thing, right? The reason why I gave you this question is because it's very similar to this question that you had on your practice test, but it's just a different application of this question. All it just says is just calculate the heat that's being made in the specific thing, and it gives you the final and the initial temperature. I'm doing a little bit of a different thing where I gave you the enthalpy of some reaction, right? And you have to figure out what is the reaction occurring, right? Is there a reaction occurring? There really, I mean, it depends on what you classify as a reaction, right? But what's actually happening is, right, H2SO4 is dissolving to form 2H plus, right? Plus O4. It's 2, right? So it's dissolving to form that. Right? Not really, I mean, phase changes are, it's a very hotly debated topic about whether it's a reaction or physical change. I think it's, I mean, it's a physical change technically, but essentially, this is the thing that's happening, right? So why is this important? Because for every mole of this, a reaction is occurring, right? So you need to figure out the moles of H2SO4, right? So you're given 8.32. 8.32, right? H2SO4, you have to find the molar mass of that. I don't know what the molar mass of that was.
98.72.
Okay, so times 98.072 grams per mole, right? And then you can take this for every 1 mole of H2SO4, 1 mole of reaction occurs, right? And then take the thing, so negative 880 kilojoules per reaction, mole reaction. Okay, quite a big number, I have to say. But that is what it is. I looked that up and that's what I got. So, yeah, and then when you do that, you get the answer for part A. I should have said what is the amount of energy? Cause yeah, it's being released because it's a negative number. So yeah, I got 74.65. I'm gonna just round there. Kilojoules being released.
Put a negative in front of it or no?
You can. You can have, yeah, you can also do that, 74.65 kilojoules. They both equal the same thing. They both mean the same thing.
Okay.
Right? I really hope Matthew is absorbing anything from this. I feel so bad. Okay, all right, okay, anyways. So, yeah, so then that's the answer to part A, right? So part B is now, this is very similar to this question now, right? So now what you have to do is you have to do Q equals MC delta T, right? And you have the Q, you have to convert this to joules though, because we have the specific heat of water, but it's in joules, right? Specific heat of water is 4.18 joules over grams degrees Celsius, right? What's the mass that you're gonna do for this?
34.
Plus.
Well, that's why.
So yeah, the reason why is like in class we did it, right? You added the solid ammonium nitrate to the water, the grams of water, right? So there is in total 42.32 grams, right? And then the delta T, which we don't know, is final minus initial. And the initial is 25 degrees Celsius, because I was very unoriginal with the initial starting temperature. And then the Q would be 74.6 or 74.650 joules, right? Okay. And then from doing all that, you get an answer of 447 about. Is that what you guys got? Do the algebra for that, or whatever. 74.650, right, divided by 42.2 times 4.18. Right, plus 25 equals F. All right, did you guys get that? But did you get that? Yeah.
What did you write?
I just wrote it, I just rewrote it so that I isolated F. Yes, the algebra never leaves you. Always with you. Always with you. It's happening. Okay, yeah, so that's how you do number 2. Okay, I'll let you guys do number 3 and 4 on your own at home. But yeah. I appreciate you guys going through with my antics. I thought I should have gone through the question on my own. I did that last session. I didn't do it for this session. That was my. Oh, my bad. It's fine. Are you guys chilling? Are you chilling, Spiro? Chilling? Okay. Well, I'll see you guys later. See you guys later. Dude, what's your name? Okay. I just kind of remember it. It's fine. There's one of me. There's a lot of. Please get home safe. Let me know if you have questions. And yeah, sorry for the confusing question, but that's the thing. It's not really. It's all the same stuff. It's all Q equals MCAT, and it's the moles of reaction. Okay. Okay. All right. Devinder.
Oh, I didn't see it. My bad. I don't want to leave you hanging.
Oh, it's not you already. Oh, that's sad. Okay. Okay. Let me know. Let me.